Hi, my name is Navneet Kataria and I'm the product marketing engineer with Anritsu for Vector Network Analyzers. So today we are going to do a demonstration of our recently launched ONA solution, which is the Optical Network Analyzer. The key components of the Optical Network Analyzer are a network analyzer. For demonstration purpose, we will be using a 40 GHz network analyzer. Then we have the EO modulator, which is MN4775A. So today we'll be doing the demonstration on a 850 nanometers and a 40 GHz system. So this is the EO modulator, which is basically from Thor Labs. And then we have our own OE module, which is characterized as per the NIST standards. So that means you have a silver standard here. What we do in our labs is that we have an NIST setup in which we use the golden NIST photo detector, and then we characterize an EO modulator with that. Because the EO modulator is being characterized as per the golden image, what we do is we then connect our OE modules, which actually the customers gets at the end of the day. These OE modules are then characterized by those EO modulators. So then that means this OE module gets a standard silver standard images, right? So that means you have the data that you're trying to characterize is almost traceable to NIST standards. About the modulator, this modulator comes from Thor Lab and it has an Anritsu part number, and it also comes in various options. So that means for different wavelengths you can have different box, or if you want you can have a tunable laser inside as well. In this particular example, the dedicated laser out and laser in portion is not there, but if the user wants to have a tunable lasers and a laser out and a laser in, so that means in case you want to characterize your own lasers at the end of the day, you can use the laser in port and then shoot your laser to the input port of the modulator, and then the optical modulated output is going to come out, right? Now, because we have the silver image as per NIST with our own OE modules, we can actually characterize any of the EO modulators. Coming back to the definition, so as per the definition, if you have these three components with you, that means you have an RF VNA, you have one EO modulator with you, and if you have an OE detector as well, that means now you can make any measurements in any of the domains. That means you can do EO measurements. That means you can characterize any of your transmitter side devices. It could be a TOSA, or it could be an assembly, it could be just a laser, or it could be an EO modulator. So you can do that. You can also characterize the receiver sides. That means you can characterize photo detectors or ROSA kind of devices, on-wafer devices, and then you can also characterize anything which is in between. So that means optical input and optical output. That means you can also measure OO domain as well. So you can characterize the EO, you can characterize the OE, and you can also characterize OO. Since the VNA forms an integral part of this entire system, you can also do EE measurements. So that means all the four domains are covered in one go. If there is a customer who does not have all the three kind of duties, say suppose there is a customer who just wants to characterize the transmitter side, so that means they just want to characterize the EOs, right? In that case, the customer can choose maybe not to buy this EO modulator, but because he just need to characterize, he just needs a receiver characterized side. So that means he can buy a VectorStar and he can buy the OE modulator, and he can characterize any of his EO kind of devices. However, in case he wants to do the photo detectors, like other photo detectors to be characterized as well, they still will need the OE detector. Why? Because you need to have a reference, and this OE detector from Anritsu, again, as I told you, comes with the silver image of the NIST standard, so that means the traceability is there. This becomes the reference for any of the photo detector kind of measurements. So moving on, we will today show you how to characterize first an EO. So that means we do not know the characteristics of this EO modulator. So we are going to characterize this EO modulator using our silver standard image like the S2P file of this guy, because we already have it. It comes in a standard pen drive like this when you buy this OE detector. We have already calibrated the VNA because I didn't wanted to waste a lot of time doing the calibration, doing the open short load and then doing it through. So I've already done the calibration. So that means I have the CHX file, the calibration file of this guy. I have the S2P file of this. Now using these two, I can actually characterize my EO modulator as well. And that makes a lot of sense as well. Why? Because as you can see, the path is that the RF travels from the VNA. So this port is transmitting the RF. It goes inside the modulator. You have a laser section and like a modulator section inside. So then the modulated output, optical output signal comes out. It goes through the cable. Then it goes into a reference photodetector. And then this photodetector converts the optical to electrical, and then electricity travels back to the VNA. So for the VNA, he's only seeing RF out and RF in. But then you have two domains in between. So basically what we can do is, because VNA has the capacity to de-embed things, so we can actually, through the entire response, and I'll show you how the entire response looks, and then we de-embed this, and then we take care of the RF cal because it's already calibrated. So if we de-embed these two things, then the end response is just of the EO modulator. Likewise, when we have calibrated or we have found out the characteristics of the EO modulator, we can save the S2P file. Now this silver image has been, or the traceability has come to the EO side, right? Now, in the next step, if you want to characterize any of your own photodetectors or ROSA kind of devices, you can disconnect these two ports, take this out, and then put your own photodetector in place of this standard photodetector. Now, because you have the S2P file of that, you have the RF cal of that, now you can de-embed these two, and then the response will be of your photodetector. Again, the NIST traceability is going to be there because in the initial step, you characterize your EO modulator using the NIST OE photodetector from us. So this is going to be the workflow of my demo today. Both these things, like the EO modulators and the OE photodetectors, they come in various configurations. Like this particular photodetector works only on one wavelength, but we do have models in which this like the same photodetector can work on different wavelengths as well, and they can go up to 110 GHz. So if you want to know more information about this OE module or the EO modulator, please go to our website and check out the Anritsu latest ONA solution.